My name is Todd Mogensen. I'm an application engineer for SE in Appleton. Hopefully in the next half an hour, I'll demonstrate the process of configuring a general purpose G120 drive and then show how to control it with an S7-1500 PLC. For this lab, we'll be working in TIA Portal version 16 and using an S7-1511F-1PN PLC, which is this guy right here you can see in the background, along with a G120 drive consisting of a CU240E-2PN, which is the head module and the brains of the drive, and a PM240 power module on the back that actually does the chopping of the power to make the motor spin. Okay. We also have some other I/O built into our training demo over here that we have. So we have the drive, the motor, PLC, and on the main rack of the PLC, we have a simulator card with some digital inputs and outputs on it so that we can actually toggle some of the bits needed to control the drive. Then down below, we have some remote I/O, which is ET200SP PROFINET I/O. And on that, we have an analog card that goes to a potentiometer so that I can turn the speed up and down for the set point on the drive. Okay. So what I'm going to do now is I'm going to switch over so that you can see my programming software, because we're going to be showing that primarily for what we're doing. So hopefully, I'm going to turn off my video. It'll allow it to go full screen so it's not blurry as well. And can everybody see my software package that is running here, TIA Portal V16?
Just want to remind everybody, most of you are on mute. This is an interactive webinar, so feel free to unmute yourselves and ask questions or respond any way you like, as long as it's nice.
Absolutely. If you have any questions, unmute, ask them, or type them in on the questions on your screen, and we can make sure we answer those as well. Okay. So, Joanne, can you see my software with the gears on it and stuff?
I sure do.
Fantastic. All right, we'll move forward unless anybody has any questions so far. This is TIA Portal. I'm hoping a lot of you have already seen this as a software package. It's the new version of pretty much the full direction of where Siemens is going in the future. So to let you know where I'm at with my software, to show that we're starting from scratch, I do have a couple things set up in the PLC, but that doesn't really have much to do with the drive yet. The first thing we did in the PLC is I have a network set up with my PLC that you can see hooked to my ET200SP I/O. And then in the each device itself, you can see that for the PLC, we have an I/O card where my simulator is on for that. And then for the ET200SP, we will have an analog input card here that my potentiometer is wired to so that we can adjust what's going on there. So if I go to a watch table, I'll go back here so you can see the PLC. I'll go back to a watch table. I can go in line with my watch table, and I have some bits set up in here, which are my very first 3 bits for my simulator card. And I can turn an on and off one here. You can see that switching on the screen. I can do a drive reset here, and I can do a drive reverse here. These are all going to be bits we're going to use on our block to control the drive. Like that, in my code, I wrote some pretty extensive code here to scale a value to 0 to 1500 RPMs over here for my potentiometer. And you guys can all see that I can turn my pot up, and I can turn it down, and you'll see the speed set point is actually a set point of RPMs that I will be able to hand out to my drive. Yeah. Right? Does that make sense?
No,
I hope so. Oh, we had a question? Okay. So, the first thing we're going to have to do in this project here, now just to show you guys that we are starting from scratch, is I'm going to go offline with everything I'm doing. And I'm going to add a new device, because as you can see, I do not have a drive in here yet. So I'm just going to add a new device. I'm going to pick drives off of the tree structure, and I'm going to go to the G120 general purpose family of drives for Siemens. And as we stated early, the control unit I'm using is a 240E-2PN. And on the side of the control unit, on the sticker with the name tag on it, it states what version of software is in that control unit. If I would have had a little more time, I would have upgraded it to the latest version of 4.7.10, but mine is 4.7.6, so I'm just going to come in here and grab that control unit. All right. Now, when we grab that control unit, it's going to show it as a visual representation, just like we saw the ET200 SP and PLC. Was there a question? Okay. With this control unit in here, you notice there's a big gray box next to it because it doesn't know what size power unit it has. It could have a very small one all the way up to hundreds of kW. So we will go under our power unit, and we will pick the proper power unit that is on our demo. So our power unit right here is just a 0.75 kW. You can see down on the bottom the part number that goes with that power unit. We'll just set that in there. So the only thing we've done so far is add the drive to our system. Okay, now that we have the drive in our system, we have to think about a few things on how we're going to get the drive to communicate and work with the PLC. Siemens has set up a bunch of different canned telegrams that will give enough information to control a drive and make a drive run. Some with encoders, some without encoders, some with just a control word, some with a control word and extra data. For this example, what you signed up for was an example using Telegram 352, which is a standard from Siemens that not only allows you to control the drive and run the drive, but it gives you some information back like amps and current and torque and faults, pretty much everything you'd want out of a general purpose drive. So everything we do here, we're going to go for Telegram 352. So in my drive, because most of Portal is a GUI that what you touch is what you're working on, I'm going to double click on the 2 Ethernet ports of that control unit. I'm going to give my drive an IP address that I would want inside of my solution. Then I would go over to my Telegram configuration. So basically Ethernet Telegram configuration, and I'm going to do nothing more than select Telegram 352. So now we have an IP address. We have a Telegram of 352. So with that, we can click over to the network view, and you'll now see the PLC, the remote IO, and the drive, but the drive says he's not assigned. So if I click on not assigned, I can say, please assign that to PLC 1, which is up here, interface 1. Automatically, the drive is assigned to be controlled by that PLC. All right, does anybody have any questions at this point? Did we go through anything too fast? We added the drive, we gave it an IP address, we gave it a telegram number, and we told it to attach itself to the PLC. I'm gonna assume silence means everybody's understanding most of what I'm saying. So, all right, so we now have a drive here. So the next section or step we would have to do with our drive is the drive won't know how to turn the motor unless it knows how big the motor is and what current it can take. So we'd pretty much need to write down the nameplate of the side of the motor. So that's the important information that you want. And in order to do that, to commission the drive, we will double click on commission, and we will click on commissioning wizard. And this will just bring up a set of screens that we can walk through and set up this drive to run for us. Since we're all great at what we do, I'm just going to say we're experts so that we can have more options to click on as we walk through here and see more of the options. Otherwise, you could pick something back here for a standard drive or dynamic drive, and it will run a macro that will point it in a little bit different direction for you. I like experts so I can see everything that's going on.
Hey, Todd, I wanted to interrupt you for a second. I think I saw a hand raise from Eric Brand.
Oh, you did?
So does Eric, it looks like you're able to speak. Do you have a question?
Yes.
Are you there? Do you have a question?
Yeah, can you hear me?
Yes,
now
we can.
Yes.
Yep.
Oh, great. I was just typing it in. I was trying to log in, and I was having trouble with the logging into the webinar at the first 2 minutes of the program here. But my question is, I missed the PLC part. Do you have to designate space, like an integer or floating point? Like, you need to designate address space in the PLC?
I've done nothing with the PLC yet to give it a space or any addresses at all. The only thing I've done is I've let the PLC know after I attached it to the PLC that I want to talk to that drive with Telegram 352.
Okay, like I said, I want to make sure that I didn't miss anything, that's all.
Yep. Nope, I just put the drive in there and I said it's going to talk with Telegram 352. And when I told it to connect to the PLC, they've now linked together at the fact that that will be Telegram 352 and it will deal with it for what we're doing.
Okay, thank you.
Sure. Alrighty, I'm going to move forward here. So we have application class. I picked expert. That'll make us feel better. We can see that the PLC is going to exchange data with the drive, kind of like start, stop, reset, and a speed. And the drive will control its own ramp function generator and ramp the motor up and down to run the way we want it to run. The next step is we can pick what type of control type we want. Linear is fine for me. This is just a demo. And we will see that this is set up to run with Telegram 352, which is 6 words in and 6 words out of the drive to the PLC, back and forth for communication. The rest of it are just bits that it tried to help you out with on a macro. So if you had some digital I/O hooked up to the drive, you could jog it. You could acknowledge faults with the I/O built on the drive as well. So we'll hit next. Our motor, in this case, is a European motor. So I'm going to leave it based in 50 hertz and 230 volts. You can pick your overload application. I'm just going to leave that default for now. We do not have a braking resistor, but my motor needs to be entered. So I'm going to enter my motor data. I'm going to select my motor type, which is an induction motor. And now we're going to fill in the nameplate. Okay. Our motor is going to be 230 volts. It's going to be 0.51 amps. 0.09 kW. Its power factor is 0.78. Now I don't have them memorized, I'm looking. The RPM for this motor is going to be 1295. Okay. Then when I click there, it will come up and it will report that all these have been entered in. So really I've done nothing but enter the motor nameplate. No holding brake. Now our reference speed and our maximum speed for this motor will be 1500 RPM. And if we issue a start, it'll go from 0 to 1500 RPM in 10 seconds. That's very slow. I'm going to make it 2, ramp up, 2, ramp down. So stop will do the full range in 2 seconds. And now if somebody hooked up an e-stop or what Siemens calls an off 3 to this drive, we could actually have it stop a little bit faster to protect somebody from getting hurt or something happening. Notice it picks its own current limit based on the overload factor. I'll say next. I'll say it's a standard drive. We aren't going to bother with a motor ID to go out and look at cable lengths or anything. And this is a summary of that drive. So all these lines that are in here are the changes from default that we made in the drive by going through this wizard. So I'll just say finish. I'll take my drive. I'll save my project. And I'm going to download to my CU320. I mean my CU240E, by highlighting the drive and hitting download. Now this is the first time, because I have reset this drive, that we will be downloading to this control unit, because everything's been restored or reset to factory defaults. So when I click on that, it immediately comes up and it says, hi, I'm a Dynamics drive. I have a MAC address, and I'm going to say load. And I probably clicked on it and did it too fast. That's usually what I end up doing. Yep, hang on. Okay, so now this is going to download all the parameters I just set up in the drive. So the entire parameter list with the changes I did and the motor nameplate. And I'm going to tell it to write it to EEPROM. So in the event power cycled on my drive, it will still maintain those parameters. So I'm making it all retentive. So now we commissioned our drive, we hooked our drive up, we told the PLC it was going to have a partner, and we've given the drive an IP address with what we've done by downloading it. It's the only thing we haven't done so far is given the drive a PROFINET name so that the PLC will exchange data with it. So we'll be doing that in a quick second when we're done here. We're getting there, the drive's clicking in the background, so I know it's moving on. Okay, so now we have a drive that has been commissioned and set up as far as parameters. I can go back to this graphical representation, which is my network view. I can right click on the drive and I can say assign device name. So you can see that everything on here is very graphical on what you pick and what you do. So I'll update my list and it goes out and it says I see a drive, which is a Synamics drive with the IP address that we gave it, and it's a CU240, but there's no name assigned. So I'm going to highlight this and I'm going to assign the name. It now knows that its name is drive 1 because that was the default drive name that came in when we popped this in. We can change it to whatever we want. I didn't see a reason to change that at this point.
Hey, Todd.
Yes.
It looks like Eric Brand might have another question, and I know you wrote it, but
yeah, I do see it. That one did come up. That is the scaling for the block. Okay, the good part is we're going to be getting to the block real soon, and that will explain how the scaling is done in this drive, and should take care of that.
And just for everybody else's benefit, the question was, does the scaling in the PLC have to be done in function block, or can it be in ladder logic? And again, I just want to encourage you guys, if you are on mute, which is awesome, but if you have a question, just feel free to pop in and speak up, because we really want this to be interactive Q&A and you get what you need out of this training.
Exactly. Yeah, it will be scaled in ladder logic on the function block that I'm putting in there. So it'll all make sense to you in a second. So, so now that we have this, Siemens offers libraries, okay, that you can download that are already created for you. And on my desktop here, you're going to see a G120 faceplate version 16, which is what I have. And then I have a blank folder here that I can unzip it and put it in, okay? And when I did that, okay, so there's the empty folder, okay? So back in Portal, I'm going to go over to my PLC software, and I'm going to go back to my OB1 or my main block. I'm going to make it so you can see it. I'm also going to go over to my libraries, and this is something that's downloaded from Siemens or from us. When we're done, if you guys want the project for this in the library, just let us know. We can email that out to you or give you a link where it is. So what I'm going to do is I'm going to say open a global library. Okay, I'm going to go to my desktop and I'm going to pick an archived library because that's what I have on my desktop. So there is my archived library. Now you'll notice there's an open as read only. If you were to set this up in your plant so that everybody could use these types of blocks, if you open them as read only, nobody could edit them, and then you could keep them as a locked system to do your machines or whatever you're working on. If you want to be able to edit them, you uncheck that box and then they will open up so that you can edit and add things to them in the library function over here as well. So I'm just going to click this so it shows up. It won't be grayed out when we open it up. So I'm going to open it and I'm going to put it on my desktop in V16 libraries. And when I open that, you're then going to see over in the global libraries window under the tab a G120 faceplate, master copies, and I have a Telegram 352 PZD Telegram for a G120 drive that we can use to control this drive. So I'm going to take this block and I'm going to set it on my network. Since this is a function block, it requires a data block to keep the data from scan to scan. I'm just going to let this one assign its own data block to it automatically and not worry about that. Just go with defaults. And you will see immediately that we've added FB10 and DB1. This is FB10, this is DB1. This is the block that now controls the drive. So all we have to do is assign these values to something to make the drive, or to allow us to control the drive. So I'm going to float this window out a little bit. I'm going to drag it over to the side. I'm going to double click on my drive. And if we look in my drive and we go to system constants, we are going to see that under this drive that there is a tag that was created in system contents for the Telegram 352 for this drive, which is drive 1, which lets you know how to talk to this drive from the PLC. So all I have to do with this is drag this tag up and set it on my address, and it will put in drive 1 PROFINET interface telegram 352 onto this block, okay? So that's a start. So now we know how to get out to the drive and talk to the drive with the PLC. The next thing you saw, you remember my inputs and outputs that I did before that I showed you turned on and off in my watch table? I can go here and I can start typing D, drive on off. I can go down to my fault acknowledge and I can say drive reset. I can go down to my reverse, direction reversal, and go D, drive reverse. So now I've set some IO on this thing. If I scroll back up to the top, I have a speed set point we calculated earlier. I'm going to put that down as my reference speed, my set point. Sorry, my speed set point, not my reference speed. Now, back to the scaling function we talked about before. Inside of the drive, when you configure the drive, there are values that show what a max scale for an analog signal to the drive mean to the drive. This block by default, because it was written over in Europe, comes up with a speed of 1500. So that just populates itself automatically the first time. I could click on it and change it if I wanted to. But we also have a reference current and a reference torque. These are values that we have to put in based on what the drive is scaled to so that it will give us the values over here that function properly coming back out of our drive. So if I go down to my drive and I go to parameters, which is what these are, parameter 2000, 2002, and 2003, we'll float this out here again. I'll double click on my parameters and I'll go to my reference variables. We will see that we have 1500 RPM, a current of 0.76 amps as a maximum, and a torque of 1.33 Newton meters. Just values straight out of the drive. So I will save that project right there. That should be everything I need to control my drive, parameterize my drive, attach my drive, and make it work. So I'm going to save, I'm going to compile my PLC, and I'm going to download my PLC. I'm going to start my module. I'm going to open this up. I'm going to turn on my glasses so we can see what's going on in the PLC. So we're monitoring this right now. I can hit a start. I'm going to turn on my camera because you won't believe me if it's not on. You can see over here, the drive is running with my start. I can reverse my speed. I can change the speed with my potentiometer. Now the nice part is down at the very bottom of here, without doing anything else to this drive or setting up any extra communication, we can see my actual speed, my actual current, my torque, and any alarms that I have. So if I give it a little speed, I'll take and I'll hold the wheel. You'll notice we have an alarm which is saying my motor's getting overloaded right now. And we also have a torque that goes up and a current that goes up. My speed, because it's just volts hertz, is assuming it's still rolling at a little bit more slippage than 508 because of the waveform it sees. But you can see that you're getting feedback with what we're doing with the drive. So that's pretty much what I had to show you guys. There's really not much difficulty in setting up a PROFINET drive and a Siemens drive with the blocks and the libraries that they give you.